Today we have to start with the Azure architecture, but before that, we'll just take a quick look at a few benefits, all right? Because there are terms that you would constantly hear about cloud. You'll say that it's got high availability or which particular system will have higher availability. So in that case, you should understand as to what high availability means. All right, or what availability in general means with respect to cloud computing. And then you will also hear terms like disaster recovery, you'll hear fault tolerance, you'll hear scalability. And in scalability, you'll hear two types of scalability, a vertical scaling and a horizontal scaling. So, what is the difference between those two types of scaling? Right, that is what quickly we'll take a look at, and then we'll continue with the Azure architecture. Cloud, you'll say that it's got high availability or which particular system will have higher availability. So in that case, you should understand as to what high availability means. All right, or what availability in general means with respect to cloud computing. And then you will also hear terms like disaster recovery, you'll hear fault tolerance, you'll hear scalability. And in scalability, you'll hear two types of scalability, a vertical scaling and a horizontal scaling. So, what is the difference between those two types of scaling? Right, that is what quickly we'll take a look at, and then we'll continue with the Azure architecture. Is something called as availability. And in the most basic sense, what availability in cloud computing means is that your resource, all right, this resource could be a VM or it could be a web app, yes, which is hosted on an app service. Any resource is up and running, yes. Availability means that the application is available. All right. Up and running means that my website or my web app is accessible. My virtual machine is accessible. I'm able to access it. All right. Now, obviously, my requirement would be to access it 24/7. Yes. As somebody who's, working on the development of a particular web application or something, right? I would want that my application is up and running 24/7. Yes. But again, there are certain challenges, there are certain limitations that also we have to consider when talking about availability. Therefore, near 100 availability is not possible. 100% availability is not possible. All right. 100% availability is a myth. We tried to reach 100. All right. So you try to go near and near and near to that 100 number, all right, a 100% number. And there are different ways to do that we'll discuss later on today as to what you can do to increase the availability and go closer to 100. All right, so you will see a system that we'll discuss that has 99% availability. Then you will see a system that has 99.5% availability. Then you will see another system that has 99.9% availability. And then we have another system in place that has 99.99% availability. All right. So 99.95, 99.99. These two are availability sets and availability zones, and we'll see what they mean. Right. But in basic sense, availability means uh, the ability of a system to be operational and accessible to the users whenever it is needed. Right. So when you go to SBI to get some work done and they say that they cannot do it because their servers are down, yes, this means that their servers have low availability. All right. And nobody wants low availability. Everybody wants high availability because it creates a good user experience. Right. People do not have a good user experience when it comes to State Bank of India. Correct. This is just an example. Now, uh, cloud service providers, CSPs like Azure, AWS, Google, all of them are competing with each other on the basis of availability. Everybody is saying that we have a solution in place that will give you the highest availability. All right. They try to ensure that services are up and running, all services, not just a virtual machine or a web application, any service that you create. all right, a database, a storage account. It's always accessible. You can always access your storage account. We'll make sure of that. All right. It's always up and running. Right. So this high availability is basically achieved through replication. All right. Whenever you want to increase the availability, it directly relates to replication. All right. This concept you have to put in your mind that any application, if I want to increase the availability of that application, then one of the best ways to do that is through replication or creating copies of whatever resource you have. For example, any data that you store in Azure, all right, any data that you store, the lowest level of redundancy for that data. When I say redundancy, is basically whenever you're uploading any data to the cloud, it gets replicated. All right. There will never be a case when only one copy of your data is saved on the cloud. Okay. Because who knows that the storage device which is being used to store that data may get damaged, may get corrupted, something may happen. And if your data is only stored in a one single place, then it's gone, right? But you will never hear any cloud service provider, whether it is Gmail, right? You have Google, you have Google Drive. You will never hear Google tell you that, listen, sorry, uh, all your files were kept in a data storage account in this particular location. We had a flood there or we had an earthquake there, so now it's gone. So we are really sorry, your data is gone. That will never happen, right? Because what Google also does is it replicates your data. At least three copies of your data is saved. All right. And that will increase the availability of any system. Replication increases the availability of any system. All right. So you have uh, data centers spread across multiple geographical locations. Yes, you have redundancy and you have failover mechanisms in place. Failover mechanisms means that if there is a system failure, if there is a data center failure, then the failover mechanism will make sure that whatever was up and running in this particular data center is up and running somewhere else as soon as possible. All right. So to meet the high availability, Azure has introduced something called as an SLA. Now, SLA is a very generic term. Maybe all of you know already what SLA means. This translates into service level agreement. Now, service level agreement or an SLA is a guarantee that Azure gives. All right. Guarantee means if I am giving you that the SLA for a particular service is 99.90%, this means that the service, the application will be up and running. All right. At least 99.90% of the time in a month. And this is the guarantee by Azure. If this does not happen and after the month your application's availability calculated is, let's say, 98%, Azure will refund you your money. They will not charge you anything for that entire month. All right. So this is the benefit of availability. Yes, it's a term that is heavily used with cloud technologies. Then you have scalability. Scalability means the ability of any system, any resource to increase or decrease, all right, its resources and services based on the demand. All right. So the ability that you have to increase or decrease the resources based on my demand. All right. So if I want more machines, more machines should be created. If the demand is that I want another virtual machine, then another virtual machine gets created automatically. That is scaling. All right. It does not mean it has to happen automatically. It could happen manually also. You can manually scale the systems as well. All right. Now, scaling basically means increasing the number of resources, all right, or increasing the configuration also sometimes of the resources. When I say configurations, what I'm saying is I'm talking about vertical scaling. If I just have to show you what vertical scaling means with a diagram, so if this is your VM, right, post vertical scaling, this becomes your VM. All right. I think the picture itself explains everything. That increasing the capacity of an existing resource. So this VM is an existing resource. And what I'm doing, I'm increasing the capacity of this VM. Let's say there was a certain amount of CPU here, there was a certain amount of RAM here, and there was a certain amount of storage here. So let's say it was 4 cores, then you have 8 GB RAM, and you have, let's say, 256 GB storage. So post vertical scaling, this will become, let's say, 8 cores of CPU, 16 GB RAM, and 1 TB hard disk or storage. So this is vertical scaling, where what I did was to an existing virtual machine. All right. This is also the same VM. It's not a new virtual machine that I'll create. Scaling does not mean that, okay, this VM is there. I will create another VM with higher configuration. So I'm scaling it. No, you're not scaling it. You're creating another VM, right? That is not vertical scaling. When you resize, there is the concept of resizing a virtual machine. When you create a virtual machine, there is a concept of resizing it. Resizing basically means if you want to increase or decrease the CPU, RAM, storage, any other configuration, you can go ahead and resize the virtual machine. All right. So increasing capacity is vertical scaling. Whereas when you talk about horizontal scaling, if you had one VM like this, post horizontal scaling, you will have multiple VMs. So now we are not focused on increasing the capacity of an individual machine. We are more focused upon increasing the number of virtual machines. All right. So you're not increasing or decreasing capacity here. You're increasing or decreasing the number of instances. Here you talk about increasing the capacity. All right. Okay. Then you have another benefit, and that is called as tolerance. All right. So we have, now what is fault tolerance? Fault tolerance is the ability of any system to continue operating properly in case there is a fault. All right. Now, in most basic sense, the fault is defined in two ways, right? There are multiple faults that can happen. All right. There are huge number of faults that can happen, but a few faults, and we'll see how Azure is ready to, continue operating even after the fault occurs. So there could be an electricity issue. Yes. There could be an internet related issue. These two are some of the most major faults that affects a data center. That there is a power outage. We don't have power to run the data center, and that creates a downtime. Right? If there is power outage in your data center, it creates a downtime. Then you are not going to be able to meet your availability expectations. All right, or any guarantee that you've given in terms of SLA or something. So electrical issues or internet related issues where your system is not able to connect to the network. These two are very common faults. And Azure has a system in place. All right. It's not a system, but it's a basic concept that they have in place that electricity, they will have multiple backups. All right. Not just one, not just two, not just three. They will have four to five to six, seven, eight backups. All right. So there is one electricity connection and then several backups available so that if there is any case of power outage, we can have power supply restored within seconds. All right. Similarly, for internet, uh, a data center in Azure will not get internet connection from just one ISPs. All right, they will have internet connection from several internet service providers. All right, they will have access to Geo also. They will have access to Airtel also. They will have access to Vodafone also. They will have access to ACT also. So all these different service providers, they'll be present. All right, and Azure will be utilizing their resources or their services. All right. Then there is a term called elasticity also. Now, elasticity is very similar to scalability, all right, or scaling. Not scalability, but scaling. Elasticity somewhat means the same thing. There is not much difference between elasticity and scaling. But scaling, when done automatically, all right, when systems scale automatically, right, the ability to automatically scale a resource up or down, right, to match the demand in the real time is called as elasticity. When it happens automatically, we refer to it as elasticity. So elasticity will ensure that any application can handle varying workloads, all right, and it can handle it efficiently. It can optimize resource usage and the cost by constantly managing the scaling. So, for example, we have something called as virtual machine scale set. All right, a virtual machine scale set, what it is, how it works, that discussion we'll have when we are talking about virtual machines, but it works in the same way to manage the cost, all right, and to also manage the utilization, right? You have to keep both the things in mind. If you only think about the cost, then you're going to create a system that is not efficient, right? So you have to make sure that the users are satisfied, the users are happy with the resources, and then the implementation that you had of that resource is also cost effective. All right. Now, a couple of more benefits and then we'll move ahead. We have a benefit that we call as a global reach. All right. Global reach basically means that Azure is present globally. There are multiple data centers around the world, not multiple, many data centers. All right. As of now, Azure has more than I think 60 plus data centers around the world. So why does Azure want to be present in these different geographical locations? Why can't it just build one large, huge data center in US and now ask everybody to access this data center, single data center? Why do we have to create so many data centers? It creates a lot of management overhead. It creates a lot of maintenance overhead, right? Then any new data center when created, you need to connect it physically to other data centers, right? Any Azure region, all Azure regions in the world are connected together. All right, they do not rely on internet exclusively for their communication. India South, India Central, and India West, these three Azure data centers in India are connected to each other, and not just each other, they're also connected to all the data centers around the world, directly or indirectly, right? So that is something that we call as the Azure backbone, right? Azure's own network that connects all Azure data centers together. So my question is very simple. Why do I need Azure to be present around the world? Why do I need so many data centers? Why do I need data centers in India? What was the need? I could have very well used data centers which are present in US, right? If latency is something that you want to address, then I could have used something which is in UAE, right? I would have received very less latency with data centers present in UAE. So what really pushes these organizations or these CSPs, cloud service providers, to come into India and build these new data centers? What motivates them? What do you think?
Disaster recovery, in case something happens somewhere, like it, they will have backup.
Yeah, that is one of the reason. That is one of the reason. But if they wanted to do disaster recovery, they could have created multiple data centers in US itself. They're a US based company. They will have employees there. They will have resources there. Why do they want to go to? For example, Microsoft has a huge infrastructure in India, right? But Microsoft might not have a huge infrastructure in China, right? But they have Azure China, right? Chinese government might not even allow them to come and work in China or to operate or to offer their services to the Chinese public, but they have data
Mhm.
centers in China, right? Or they might not have a huge infrastructure present in, let's say, UAE or some other European country, but they do have a data center present in that European country. Yes. So yeah, disaster recovery, backups and all, it's fine. That is one of the purpose that they solve, right? Having data centers in multiple locations, because in case there is a disaster in, let's say, US, right, and it's a huge disaster, then the data centers present in that particular location where the disaster happened, they're going to get affected, right? So we need to have data centers outside of that place, which could be used to transfer data, to transfer applications. Yes. But why does it need to be present in India, in Australia, in Japan, Tokyo, wherever, right? Korea, wherever they are.
Faster data availability.
Yes. Latency is something that I discussed, initially itself. I said, yes, it will solve the purpose of latency. Why is it not typing? Wait.
Shreyas, you
Latency
means
is
latency means close to our place to from where we are
Latency means
accessing.
that you're able to access data faster. All right. There is no lag. You don't have to wait for to receive that data. All right. You don't have to wait for long. Latency is already an accepted answer. Yes. Any resources hosted in a data center in US, when you're trying to access it, there would be some lag. There would be some latency when you're trying to access it, and people might not like this latency. People will want it to be a very quick solution. So latency is there. Another very important factor is the local government regulations. All right. How many of you heard of this term called GDPR? Has anybody heard? Yes, no.
No.
So GDPR stands for uh, General Data Protection Regulation. All right. GDPR regulation is something which is implemented by the European Union. All right. European Union basically means all European countries coming together and enforcing something, some regulations they've enforced. And this regulation, its main objective is to protect the privacy and the personal data of all European citizens. All right. of all European citizens, and therefore it prohibits any cloud service provider, all right, or any other organization to store data or to store personal data, private data related to any European citizen outside of Europe. All right. So now there is a need to build infrastructure in that particular country, right? Because the government does not allow the data to go out. And something very similar happened in India also. So if anybody over here had an Amex card, right, or a MasterCard, they would know that around 2020, 2021, right? I think from 21 to 22 or 20 to 21, there was a time when American Express was, asked by the Indian government to not issue any new cards. They were asked to stop their operations. Similarly with Mastercard. The reason being, these two organizations were storing the data related to Indian citizens, the private data, the transactional data that they are doing outside India. All right. Both of these are not Indian companies. They were storing data outside India wherever they wanted. But then the government of India came with a regulation saying that any personal information of an Indian citizen should not leave this country. It should be stored somewhere on Indian soil. Now, this did not apply just to Amex and MasterCard. These two are just examples of it, right? Examples of organizations that got affected. But there are thousands of organizations now who had a job at hand that they had to now store data related to Indian citizens inside India, right? And that gave an opportunity to cloud service providers that, okay, now there is a huge demand which is going to, arise for data centers present in India. Why? Because the government now wants them to store data in India. All right. That is one of the regulation, government laws, government regulation is one of the things. Another thing is any geography. When I say geography, basically, let's say India is a geography, Australia is a geography, Europe is a geography, North America is a geography, something like that. Any geography, if there is a huge IT infrastructure, right? That means a lot of uh, you know development happening in field of information and technology. Then it makes sense for companies like Amazon, Google, and Azure to come to that country because they have a huge IT infrastructure and build their data centers there. Right? That is why you will see there is hardly any data center in the entirety of Africa, except South Africa, which has two data centers. South Africa has two Azure data centers. No other African country has a data center. Similarly, except Brazil, no other South American country has a data center. And the reason is very simple that they do not have a very high or very huge IT infrastructure in place. All right. So these are some of the reasons because of which, Microsoft has this concept of global reach. All right. So these are some of the benefits that you should know about and the reason as to why they're there. The next thing that we are going to discuss is what the data center looks like from inside. So now we are done with the basics, right? In the basics of cloud, we covered the benefits, what is cloud computing, the different cloud models, public, private, and hybrid cloud. And along with that, we also saw the different cloud services like infrastructure as a service, platform as a service, and software as a service. Now, as I had told you before, our discussion about private cloud and hybrid cloud ends now. All right. We are not concerned now with private cloud. Our discussion will solely focus on public cloud. All right. Cloud services which are provided by Microsoft, Amazon, Google, and various other organizations. There are other clouds as well. There is IBM cloud, right? So a lot of different clouds are there. Now, this is what a data center looks like from inside. All right. And to better understand the architecture, you need to remember some terms. All right. Some of the terms which are used in Azure. So the most high level picture that you can see in a region is like this. This is a building, which you also call as a data center building, right? A data center building is also called as a zone. In Azure, we use the word zone for data center. All right. So going forward in the course, if you ever hear the word zone, please understand that we're talking about a data center. All right. Inside a data center, you have racks and so on. These racks will have servers on them, multiple servers, not just one, but multiple servers. All right. Now, this is one of the architecture. This is a simple architecture of a data center, but you would have heard that I've used both the words. I've said data center also. I have said region also. Now, what does a region mean? A region is nothing but a geographical location where we have an Azure data center. Any geographical location that has an Azure data center becomes a region. For example, we have a data center in Mumbai that becomes India West. We have a data center in Chennai that becomes India South. We have data center in Pune that becomes India Central. So any place, any geographical location, if it has one or more than one, please focus on this line very carefully. Data center or data centers. I would say one or more data center. You could have a scenario where you have a region, let's say this is India South, and there is one data center building, there is another data center building, and there is another data center building. These are all your zones. Now, inside these data center buildings, you will have racks, multiple, and these racks will have the servers. So, please try to understand the basic difference between a region and a data center. A region is a place where data center is present. There could be just one data center or there could be multiple data centers. All right. Now, if you go inside a data center in Azure, this is what it'll look like. All right. If you go inside a zone, so this is a view of a Microsoft data center present in Dublin, Ireland. All right. So whatever region they have there, this is a view from inside that region. Now, what you see is a series of racks. All right, placed next to each other. This is a series of racks. Each rack will house multiple servers. All right, that is the basic arrangement or the architecture of a data center in Azure. Now, each of these rack, a single rack, all right, is always connected by electricity and internet. All right, so there will only be one cable for electricity for the entire rack. If you look at your screen, you will see there are two cables dropping down, right? One is orange in color, one is black in color. So one of them would be carrying internet for the entire rack, and one of them would be carrying, let's say, power for the entire rack. If any of this cable breaks, if there is any fault with the cable, right, does the entire rack loses its power or just a few servers? What do you guys think? If this internet cable breaks, do all the servers present here lose internet access or only a few servers?
Few servers. Only that rack.
Only this particular rack, right? All the servers in this rack.
Yes.
Yes, they will lose internet access. They will lose power access if there is a power failure. See, when if you remember, we discussed about fault tolerance. Now you'll be getting confused as to, he said that there is fault tolerance in place, there are multiple power backups, then why is he saying that the power may break? There are power backups, but that power backup will not get individually connected to all the racks. The power backup is for the entire building. All right, for example, you have, let's say, inverter in your homes. The inverter is there, but what will happen if the wire of your fan breaks? Then your fan does not work. Whether there is power backup or no backup, that is a fault with the fan. Similarly, what I'm discussing here is a fault which is there with the rack itself. So any fault that occurs, can I say that it occurs on the entire rack? Any fault that occurs, it affects the entire rack. Yes or no?
Yes.
Yes. And that is why racks in Azure are called as fault domains. The name given to racks is fault domains. So wherever you hear the word fault domain, just think of racks in Azure. All right, in the Azure data center. Now that is there. Let's talk about servers as well. So you discussed what racks are called. Now let's try to identify what servers are called. Servers are placed sequentially on the racks like this. The thing about servers is that they are regularly updated. There are regular updates happening on these servers. All right. When I say regularly updated, there is an entire process that happens. All right. And servers are never updated in parallel. The updates will only be take place, or you know the updation will only happen in sequence. So that means that first this particular server, server number one, will get updated, restarted, then I'll go to server number two, updated, restarted, then I'll go to server number three, update it and restart it. So whenever you are updating in a data center, right? When you're updating servers, it happens or it occurs on an individual server level. Like fault happened on the entire rack level, updates take place on the server level. And that is why servers are called as update domains. So you have fault domains, which is called as an FD, and you have update domains like this. All right. So these three things you have to remember, that a data center can also be called as a zone. A rack is called as a fault domain. A server is known as update domain. Is that clear to all of you?
Yes.
Now moving ahead, we have Azure regions. All right, so we've already had a brief discussion on region. A region is any place in the geography which has an Azure data center present. So currently we have 60 plus regions in Azure. Yes, regions are made up of one or more data centers in close proximity. Yes. Uh, so you can see on your screen there's a cluster of regions in North America, but you hardly see something in South America, which is apart from Brazil, you will not see any other data center in South America. Then you will see a lot of data centers in Europe, a lot of data centers in the Asia Pacific region, but then you do not see any data center in the African region, except South Africa, right? Which obviously has a lot of IT infrastructure in place. So it's a good option to build a data center there. Now, the things about data centers is that you know, few moments ago we discussed that why do we need these data centers around the world, and somebody responded that because we need to have another data center in place in case there is a failover, all right, or in case there is the data center has gone down due to some reason, then we have other data centers operational. Yes. So now my next question is around that concept, what you already know. And I want to ask if you are able to look at this screen over here. Yes, this is what you see in terms of data centers, right? Now, my question is, for example, South Africa West has gone down due to floods or an earthquake or a fire, whatever it is, whatever the reason may be. South Africa West has gone down, right? Where will Azure sends? Where will Azure send the data which is stored in South Africa West? Do they send it to Brazil? Do they back it up to India South, or do they back up to South Africa North? Which one do you think? Where do they
South of
send this data? South Africa North?
yeah.
Yes.
Yes. The reason? Any
Yeah.
reason that you can think of?
As per the policy, so it should not move some other country.
Yeah, that is there. That is a very important reason. And another thing is that you try to put it to the nearest data center. Correct?
Yeah. Okay.
Now, so basically, what you are trying to say here is that whenever a data center goes down, Azure will try to move the data present in that data center to some other region. Correct? Yes? Yes or no?
Yes.
Yes. Now, my
Yeah.
question is, do you think this is all pre-decided, or Azure will sit and decide in case of a disaster? Or do they already have a plan in place that if this particular data center goes down, I should be transferring data to this particular data center? Is there a plan in place already, or are they going to discuss on it and then decide on it if and when there is a disaster? What do you guys think?
It should
There
be
is a
pre-decided,
plan.
Yeah,
planned.
yeah, it should be pre-decided, and that is what happens. That is where we get the concept of region pair in Azure. All right. So apart from region, you also have a concept of something known as a region pair. Now, my question is, let's say I have a region in a country, let's say, and 30 kilometers apart, I have another region R2. Should I consider this as a region pair? Should I take this as a region pair for R, let's say for R1? Should I consider R2 as a good region pair? Yes or no? Is it
Yes.
possible?
Yes.
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 Uh,
But let's
no.
say there is an earthquake. So do you think it will not affect both of them? Let's say there's a huge earthquake. Does it not affect a 30-kilometer radius, or there is a huge floods, yes, that have taken over? So in case of floods, chances are both of these regions are going to go down. Correct?
Yes. Correct.
Yes.
Yes. So therefore, it's not a good idea to select regions which are very close by. And for that reason, yes, we have certain conditions for two regions to be region pairs. And the very first condition is that they should be at least 300 miles apart. For any two regions to be a region pair, they should be 300 miles apart. That translates to roughly 480 kilometers. So there should be, you can take it as 500, all right? So there should be at least 500 kilometers of distance between any two data centers for us to consider them as region pairs. All right, not data center, but between two regions. All right. So the concept of region pair is that if one region goes down, I will be replicating my data to the other region, right? And this is a bidirectional connection. If North Central US goes down, I am going to transfer this data to South Central US.
Shreyas, replication were already done before, right? It is just the pointing.
See, replication of particular resources are done, not all resources. All right, some resources will have a failover mechanism in place. All right, that if there's a failure, then I have to transfer the data to this particular region.
You mean
All right,
at the time of failure, they are replicating the data to the next region?
to the region pair.
Okay, is it possible? Okay.
Hmm.
You
Yeah,
mean at the time of failure, they are replicating to the next region, nearest region.
not the nearest region, but the region pair that they've decided.
Region pair, correct. Yeah,
See,
yeah.
there are several. See, failure is not the only reason for region pairs. There are multiple reasons. For example, let's say you have two regions in a country and they're both hosting an application. All right, an application is hosted. So currently you have the app 1.0 version, right? Tomorrow you come with app 2.0. So there is sequential rolling out, all right, of updates. That means that app 2.0 will not be updated on both of these regions. All right. First, I will host it here. I will make sure that it is running properly. Users are able to access everything. There is no problem. There is no bugs with the application. And when everything is successful, then I can go ahead and release it on the other region as well. So now everybody who was trying to access this application through a load balancer, they were either directed to this region or this region, right? If they were directed to this region, they were only able to access the earlier version of the application. If they were accessing through this region, then they were getting app 2.0. So now they will get, once I have rolled it out here, it works properly, then I can go ahead and roll it out in the other region also. All right, that is also a benefit of region pairs. All right. Now, these region pairs, again, as you said, are predefined. We already have a list that you can see on your screen, that if any of these regions goes down, this is just an example. There is a list for all the regions in Azure, right? If India South goes down, I'm going to transfer it to India Central, that is Pune. Yes. If but if you look here on your screen, what about Brazil South? It does not have any other data center or a region in Brazil. It does not have any other region in entire South America. So what happens in this case? So with Brazil South, what happens is that the data goes to South Central US here. In case you want to create a region pair with Brazil South, the region pair is South Central US. Now you will say South Central US is already in pair with North Central US, and that is absolutely correct. So this means when North Central US goes down, it is going to transfer data to South Central US. When South Central US goes down, it is going to transfer data to North Central US. It's not going to send it to Brazil. Only Brazil is a one-way connection where if Brazil South goes down, then we are going to transfer data to South Central US. South Central US will never transfer any of its data to Brazil South. So after region pairs, we also have something called as sovereign regions. All right. Now, the concept of sovereign region is very clear, that it is a region which is created, built, defined for a particular entity. All right. This entity could be a business, it could be an organization, it could be a company, it could be a government. All right. It could be the government of the country also. So sovereign region is any Azure region which is reserved for a particular entity. Those regions are called as sovereign regions. All right. So the general regions which are accessible to all the public, they are called as Azure global regions. All right. And then you have these sovereign regions. Now, who can access these sovereign regions? Do I have access to it? The answer is no. Or maybe yes, also, depending upon which sovereign region are we talking about. For our example, we'll see two sovereign regions. The first one is a US government region. All right. So the US government asked Microsoft to build a data center for them. All right. Because they wanted a data center, they wanted several compute units, they wanted, storage, and they wanted this region only for themselves. Only US government employees and officials who are authorized by the US government will have access to this data center. General public cannot access this data center. It is reserved for US government operations. All right, even though it is built by Azure. So it is considered as a sovereign region. Now, by the sound of it, what does this sound like? Does this sound like a public cloud or a private cloud? Which one do you think?
Private.
Yes. The sovereign region of Azure US government is a example of private cloud. Then we have another example of Azure China. Now all of us know that it's very difficult to do business with China. Yes, they do not allow these organizations from outside to come and operate in China. There are very strict rules for them. They either have to do a transfer of technology, they have to explain as to what their application is doing, how it is doing it, which generally most of the companies they don't want, or they would ask you to set up a joint venture with a Chinese firm. All right, do a partnership with Chinese firm, launch your product in China through that Chinese firm, right? So what that does is it made Azure also to partner up with a firm called 24YNet. 24YNet is a Chinese company that runs and operates Azure China. So Microsoft also had to do a partnership with a Chinese firm in order to launch their product in China. So 24YNet is a company that works on Azure China or that operates Azure China. Now, even though there is a limitation on the geographical boundary as to who can use this data center is open for all Chinese citizens. Every Chinese person, any uh, you know person who has a Chinese identity is able to access, or anybody trying to access it from within China is able to access this data center. They'll be able to do it. All right. So it's not like US government region where they have specifically said that I want only these particular people to be able to access this data center. This is open for general public. So what do you think? Is this an example of private cloud or a public cloud? What do you think?
It's public.
Private
Yes.
only.
Azure China is a classic example of public cloud.
Okay.
It's not private, right? It's not reserved for a few people. It's open to general public. Just there is a geographical demarcation of as to what the definition of public is.
Okay.
All right, but it is available over the internet in China. Everybody can access it. US government region is not available over the internet in US.
Okay.
All right. All right then, guys. So we'll pause here for the day. All right, and we'll continue from here on Monday. We do not have classes on Saturdays and Sundays, so we'll continue from here on Monday. All right. So if you have any questions, feel free to ask, or we'll close the session now. Thanks a lot, everyone.
Thank you.
Yes, is it possible? Can you share the Python related details so
Yes,
that
I'll be sharing it today. I'll be sharing it today along with the document and
Okay.
the video lecture series. Both of them I'll
Yeah.
share.
Yeah. What are required prerequisites so that we will
See, prerequisite is uh, just a general understanding of Python, right?
Yeah.
But to grow in the role, you need to have an in-depth knowledge of at least Python and SQL. To become a successful data engineer, you should know Python. You should know mathematical libraries in Python. Yes, data libraries in Python. You should know them. And SQL, you should have a very good hand in SQL.
Yeah, we are very much aware of SQL, but Python we are not that much. Yeah.
I will
Yeah.
share the
Okay.
video lectures today.
Sure. Thank you.
All right. So thank you for joining, everyone. I hope to see you all on Monday. Thanks a lot, guys.